Good morning, good afternoon, or good evening, depending on where you are tuning in from today. And thank you for joining this TechStrong learning experience with ngrok. My name is Tip, and I'd like to welcome you to our TechStrong learning program. This session will be available afterward on demand. We will also be sending you a link to the recording after we conclude. Please send any questions that you have to the Q&A panel on the right side of your screen, and join us in the chat by telling us from where you're tuning in from. Share your experiences, your comments, your understanding of the matter. We want to hear it all from you and engage with you. Any questions that we're not able to get to, we will follow up with you shortly after the program concludes. We also have handouts available for downloading in the resources section. Now, let's kick off today's topic. Is your API gateway ready for multi-cloud? Thank you everyone for joining us today. We have Alice Wasco and Joel Hans with us today. Joel, can you take it from here?
Yeah, thanks so much, Tip. I'm Joel. I'm a senior developer educator at ngrok on our DevRel team and the solo representative of ngrok in the Southwest. I'm in Tucson, Arizona, which is very lovely this time of year. And at ngrok and other startups based in San Francisco to Athens, Greece, I've written probably hundreds of thousands of words on observability, Kubernetes, infrastructure, Linux administration, and of course, all things ingress and gateways. So very happy to be here and to talk with you all about going multi-cloud. And with that, I'll pass it over to Alice.
Thanks, Joel. I'm Alice. I'm a person who works at ngrok. I'm living in Oregon right now, and I work on ngrok's developer growth team. So working on mostly the stuff that's a little bit closer to the people using the products. I guess with that, why don't we just jump into the slides?
Yeah, right before we get started, I just want to kind of frame the discussion
Sure.
and talk to the people here in the audience. Let's talk about you for a moment here, because if you're here, you're probably pretty invested in getting APIs online in a really simple way, one that's modular, flexible, and scalable, all those good things that infrastructure folks talk about and want to get to. You probably you probably have some way of doing that, but you know that when it comes to multi-cloud, it's a whole other equation. Infrastructure is hard, networking is hard. Once you try to take all of those pieces into multiple clouds and bridge them together, that gets really, really, really hard. So we're going to get into ngrok as a product in our demo that Alice is going to do, but just in short, ngrok is a composable API gateway, and it has all of those things you're looking for, those qualities. It's modular, it's flexible, it's scalable. We'll show you about how all of that works on a really technical level, which I'm really excited about because multi-cloud is an area that we have a bunch of really cool new features to get into. But let's also, before we do the demo, let's take a few minutes to just talk about why multi-cloud, what are the problems that people typically face, and what some of the tools and resources there are available for you all to get started. So yeah, Alice, why don't you go ahead and fire up the slides and we'll dig into it.
Sounds good. Thanks. All right, I'm going to assume that you can still see this when I full screen the slides.
Yes, we can.
Awesome. Yeah, so multi-cloud API gateways is kind of going to be today's focus. I'm sure there's a lot of other complexities and issues with multi-cloud, but right now we're mostly just focusing on the problem case of how do I get traffic into my multi-cloud setup? So before that, what do we really call a multi-cloud gateway? I'm going to define it as really any kind of gateway implementation or solution that is going to help you get all of the API traffic, any kind of traffic you need across multiple different cloud providers and environments. Oftentimes when we think of multi-cloud, we're sort of limiting that to the case of like, hey, I have like an AWS cluster and I have a GCP cluster, and how do I connect these things together? But it doesn't necessarily have to be different providers. It could be multiple different environments within the same cloud provider. And they could be totally different environments as well. Like you might have virtual machines, you might have Kubernetes clusters, you might have separate devices or servers that you operate. Whatever the use case is, you've got a whole bunch of different devices running at different parts of the internet, and you need to be able to connect them up together. Um, and beyond that, you want to obviously make sure that all of the traffic you're processing is secured with authentication, unless it's public access, and that you have a reliable way to kind of manage all of the monitoring, logs, events, data, that kind of thing from all of your traffic processing. Also, it's always super important whenever you're setting these things up to have good tools to be able to modify that traffic. So, what are some reasons why you might want to go multi-cloud? So, obviously, you get one benefit, which is straight away availability, right? Like if you are operating, let's just say you have a Kubernetes cluster and you're running an AWS, you probably don't want to have a single point of failure. And you also probably want to have better latency for people in different regions. And so you might duplicate that setup across multiple different regions. So you can route your users to the closest region for reduced latency, and also have failover in the event that your primary region you might have started with goes down. Another use case is acquisitions and mergers or cross-org collaboration where you're working with another company. Whatever the case may be, you have your setup in one cloud, they have their setup in another cloud, and now you guys need to consume each other's resources directly. And that may not be the type of thing where it's a public API that you can just route over the public internet. You need to find more private and secure ways of connecting those environments together for more sensitive business data. Cost optimization is another one. So depending on the region you're in, you might want to do something like AWS hosting in the US. You might use like Alibaba Cloud if you're in China. And depending on where your regions are, there also might be limitations on things like GPU resources in the clouds that you are using. So some people might want to just grab all the available resources they can for the price that they're comfortable with in each region and try to find a better deal in another region. Another one is compliance with regional regulations. So there's all sorts of stuff like GDPR and stuff where, for a lot of reasons, it's best to try and keep like the data of your users central to the region that is their home. There are a lot of regulations and stuff about that. I'm not going to pretend like I understand them all, but that's generally something that you might run into. Another one I think I already touched on is combining different kinds of workloads. So you might have like a Kubernetes cluster, virtual machines, you might have like a stuff in your own office or home environment that you want to connect up as well.
Awesome. And we've got some, I fired up the poll right as you were starting up that slide, Alice, and we do have some results trickling in, which is exciting. We have availability and redundancy up at the top spot right now. Things have been sort of moving dynamically as people add their responses. That's 31%, followed by the specialized features unique to different cloud providers. I think again, like the access to GPUs is a big one right now as people are trying to fire up LLM models, maybe self-host those things or like keep them within their own infrastructure. And they need to be able to access those resources in a reliable and secure way. Let's see what else. Mergers is moving up a little bit, as is compliance with regional regulations. So very exciting to see kind of like what people have experienced before. I was going to ask you, Alice, really quickly, like you are, kind of in conversation with some of ngrok's earliest multi-cloud API gateway customers. And I'm curious about like, what have you seen as trends from people who are already looking at ngrok?
Yeah, I think, what do you mean really in trends, I guess? Like, I think for sure the most common use case is availability and redundancy.
Okay.
I think that's where like a lot of people start out, especially with startups. They are not quite at the scale where they already have that kind of infrastructure in place, but they're growing, and so they need to consider it. And so for a lot of smaller businesses, that's like one of the first like big challenges they have with scaling, is thinking about how to set up different regions and stuff like that. Yeah, is there more context on that you were curious about, or?
I don't know. I was curious if kind of since you've been in the API gateway space for a while, if you've seen
Yeah.
these reasons like shift over time. I mean, I feel like the specialized features is maybe one that has changed in recent history, as we just talked about. But yeah, I mean,
Yeah.
it's very cool to see where people are landing in terms of this audience.
Yeah, I honestly haven't really heard the use case for specialized features in different providers so much up until the most recent, like 2 or 3 years. Before then, it was kind of all, availability and redundancy. I need to scale out into different regions. I want to minimize latency. I want to protect my users' data by keeping it in their home country, kind of thing. Um, and then those are mostly the things you're hearing from businesses that are in their growing phase, and from businesses that are very mature businesses that are kind of just replacing legacy networking stacks is more on the line of mergers, acquisitions, where all of a sudden they own another company and their cloud setup is totally different and they need to figure out how to make them work together.
Yeah, exactly. I think that's something that within ngrok we've been seeing a decent amount lately is, yeah, I'm all AWS. I've acquired a company that's all GCP, and how do we deal with this situation without causing like months of rewiring or migration or all sorts of really complex patterns that no one really wants to deal with. So um, awesome. Well, with that, kind of mentioning that like AWS, GCP specific things, maybe we can skip over to the next slide and
Yeah.
talk about, I'll talk of just a little bit about some of the tools and technologies that are available for multi-cloud API gateways right now. So the first 3 points here are cloud specific tools that each of these cloud providers makes available to those who are using, AWS or GCP or Azure. AWS has their API gateway tool, which is it's serverless, it's scalable, but of course, being an AWS specific tool is really designed just for connecting services that are running in different AWS services, whether that's like Lambda or EC2 or all sorts of other things. Works really great for integrating that, but doesn't really have any sort of capability to go beyond that. We have Google Cloud Endpoints that has their API gateway in Apigee. They kind of have this ecosystem of different API gateway related tools. Consistent experience across them all, but we didn't finish that sentence there. But kind of the same problem there of these are GCP specific things, and it's quite difficult to break out of that barrier if you are looking to go multi-cloud. Kind of same story for Azure. Great if you're kind of all in on the Microsoft ecosystem, but will require extra complexity if you're looking for multi-cloud. You have kind of then this whole other ecosystem of what we're calling deployable gateways, Kong, Nginx, Envoy, et cetera, et cetera. There's many different open source options there. You get the benefits of self-hosting an open source product, which is like you have complete control. You can deploy it anywhere that you can deploy Kubernetes, or you can deploy a Linux VM. These are very powerful, configurable, trusted in many cases, thinking of like Nginx in particular. But that does come with a lot of setup and maintenance, just in terms of like, how do you get them all to sync with each other? And then you have like, we think of ngrok as maybe a different category. And we'll get into like why that is the case through the demo. And kind of show the primitives that make it all happen. But we think of ngrok again as composable, easy to use, and it works everywhere. And again, we'll kind of dig into the whole ngrok story in a little bit. So yeah, do you want to hop to the next slide? The challenges of multi-cloud. I've been touching on these a little bit, but it's like everything is all the complexity and troubles that you had with implementing a good API gateway within a single cloud are multiplied. And it's not just like it's not just twice as complicated. It's, 10 times, 100 times more complicated than what you were dealing with before. You integrating the provider specific tools, whether they're firewalls, VPNs, VPCs, authentication mechanisms. These all get really difficult when you try to go multi-cloud. Trying to have a consistent security policy or configuration across all these environments is really difficult. Like, let's say you want to use JOTs for authentication, and then you want to also implement, say, a rate limiting policy across all of your APIs. How do you do that across different providers in a consistent way? That's super challenging. Observability is also difficult because you have different cloud platforms. They each have their own observability tools that you need to wire together, or you can try to export all of the data and ship it into a completely different platform. And then you kind of need like data engineers and all sorts of other like really sophisticated roles to be able to deal with that. And this just leads to a fragmented experience for you. Each cloud provider has different primitives and API management tools, and you are left kind of responsible for knowing all of them and then making the experience for other people in your team, like say API developers, like consistent and good for them. And that's just a huge challenge. And we have, I think, some architecture diagrams to kind of show why and how these are challenging. So looking first at the cloud-specific API gateway architecture, again, this is AWS, GCP's, Azure's specific things. You have clients, all the clients are coming into one API gateway, and those are, you can configure and observe that API gateway from one place, which is great. And those requests are then going out to different load balancers and then into different API services. But if you maybe squint and look closely at this diagram, you see that we have two boxes. We have Cloud A and region or availability zone A, and then we have Cloud A, region, availability zone B. So like using these cloud specific tools is great if you want to have multiple regions within the same cloud provider, but there's not really an architecture diagram that we can make that also allows you to have, cloud B, cloud C, etc., within the same kind of simplified architecture. And that's where all of those challenges come in. And then I think we've got one more for deployable. And Alice, you have done a ton of work in deployable API gateways, so I think you wanted to take it from here.
Sure. Yeah, I previously had worked on Ambassador EdgeStack, Emissary Ingress, and Envoy Gateway. So I have a lot of experience with the self-deployable API gateways. And while I love being able to host my own software, there are a lot of drawbacks with them. Namely, as Joel mentioned before, how do I wire everything up together? So typically with the self-deployable ones, you're going to have each one deployed closest to where it's routing to the services. And then things like security, rate limiting, etc., those are all, for the most part, going to be stored locally, or at least applied locally within that API gateway. So if you wanted to do something like make sure that no matter which region or cloud your clients are connecting to, we establish, consistent rate limiting and stuff, that gets really difficult because then if you want to think about something like OAuth, right? Like let's say I've connected to Cloud A and I need to authenticate. I need to make sure that Cloud B also has like something like the same ability to process a JOT that I've received from authentication in Cloud A, so that if on a subsequent request I get routed to Cloud B, I don't need to re-authenticate. So those types of things can get a little bit more tricky where you need to manage like duplicated config or similar but slightly different config across multiple API gateways, and make sure that they're all synchronized together and operating correctly and that the config is actually getting picked up and doing what it's supposed to do. If even one of them, some kind of security policy like the JOT filter isn't correctly applied, you could be letting in a bunch of unsecured traffic. Additionally, things like observability and configuration all tend to live pretty close to them. Some of them do have offerings where there's like a centralized cloud service. Typically, they're more designed to work with these things closer, or the ability to export them as far as like observability for things like metrics and traces to something like Datadog. And so that kind of web of like, how do I figure out where this traffic is going to go and make sure that behavior is consistent across all of them gets really complicated. Like a pattern that I've seen pretty frequently is that a lot of customers will have, kind of a master set up for specific regions where, let's say for like the whole like North America, South America, they have like one API gateway that is solely responsible for load balancing within all of the other regions. And so you have like a multi-layered approach where there's one that administrates like where is this request going and doing some initial checks and stuff like maybe sanitizing some headers, that kind of thing, before passing it off to another instance of your deployable gateway that is going to do more thorough filtering, processing, and routing to those APIs. So it is totally achievable. Things like Linkerd and Istio make it possible to have a service mesh as well, where you connect your APIs across clusters. But overall, the cost and complexity of doing this tend to get pretty insane. Either you go with an open source approach where you might need to figure things out a little bit more yourself and be more of an expert in these tools, or you're going to be spending a ton of money for enterprise solutions that give you a little bit closer to that all-in-one package you're looking for. And so ngrok is different in the sense that it is what we kind of call a cloud-based gateway. And so all of that sort of stuff just lives within the ngrok network. So this enables you to get a lot of benefits. So it's really quick to set up. You don't really need a lot going on in your system. The config, what config you choose to keep and where is pretty much up to you for the most part. Tunneling and routing is seamlessly across environments. You can do things like hook up embedded devices with Kubernetes clusters and VMs and whatever you want to bring. It doesn't really matter. It can all get connected together. It's super easy to expose workloads or keep them private, and it's secure by default. So we automatically do everything through TLS. If you want to turn that off, you obviously can. You can bring your own certs, your own domains, etc. But just getting started with ngrok will provide you with certs and domains to get started with. Oh yeah. Another thing too is that while a lot of these previous API gateways are pretty opinionated about their config, like many of them might be like Kubernetes native, but not really work so great off of Kubernetes, or have one kind of configuration option, and then you're kind of left wondering like, hey, how do I use this in another kind of use case? ngrok has a lot of different ways where you can use it. We have a CLI, so you can just use commands directly from your machine. So that's great if you want to hook up things like virtual machines, embedded devices, where you just want to run the binary and be able to connect all of your stuff together to the ngrok network. There is a web interface if you prefer doing things with the UI. And we have SDKs and APIs as well if you would rather do a more custom scriptable approach to enable things like CI/CD use cases where you want to run it in more of like an automated tooling kind of way, where you're very frequently like spinning up and destroying your networking infrastructure. And so with ngrok, we're getting a lot closer to that initial use case of like, hey, we just want like one unified platform that does all this stuff for us. And so with ngrok, all of the clients will connect to ngrok's API gateway, which will then route to your agents over a secure tunnel. And then all of your configuration, security, and observability is centralized in the ngrok cloud. And so you still have the ability to like export your traces and metrics and stuff, but you get that central like unified observability, security config out of the box, which is really nice as well. So it just makes it really easy to add new stuff to the network and route to it once you've already got it set up. It's not like a Herculean challenge to add your nth new, Kubernetes cluster or VM or whatever device is. It's just as easy as adding your first one.
Yeah, awesome. And one thing that I wanted to mention that architecture diagram doesn't really show much of, and I think we're going to get into this a little bit in the demo as well, is that you can actually, like, while you can configure everything like centrally, kind of have like a single front door for all your different APIs and different clouds, you can also configure the agents and operators. You can like compose additional rules on how each of those or each API service responds or behaves on top of the centralized one. So you really have, and it uses kind of all the same configuration strategies and like the methods that you would for the central one. So you can really get like super fine grained with controlling API traffic from like a very unified interface across all of them.
Yeah. So, obviously we're biased. We work for ngrok, but I think it's pretty cool. Otherwise, I wouldn't have wanted to come work here. So I think like these, I just wrote down some of the things that I think are big benefits of ngrok versus the alternatives. So with a lot of the alternatives, things like Envoy, Istio, etc., like you really need to be a subject matter expert in them in order to reliably run them at this kind of a scale we're talking about with the multi-cloud setup. Like they're typically things that are very easy to follow the quick start, but then the second you need to deal with like an actual real world use case, the complexity explodes. And there are a lot of foot guns, especially with something like Istio, where yes, you have the ability to get under the hood and, you know, manage configuration and do really super specific things, but at the same time, that gives you such an easy opportunity to just blow up your config and now nothing works properly. With ngrok, the config, in my opinion at least, is very easy and it's super quick to just instantly get connected in online or get connected privately to the rest of your network. Cost efficiency, you know, this was one of my points of gripe with some of the other ones is a lot of them require you to reach out to sales in order to buy them for a plan. They oftentimes have really high upfront cost enterprise licensing that make it really not viable for small businesses. If you're a huge business with a ton of cash to spend, maybe that's not as much of a concern for you. But for me, even using it personally for things like, you know, game servers and stuff like that for my friends, like you can just add credit card, pay a couple bucks a month for the little bit that you're using, and then just manage things however you prefer. ngrok, I feel like, has much simpler configuration to a lot of these, especially something like nginx or Envoy, where the configuration is deep, but also very, very convoluted and, you know, thousands of lines long. Again, if something goes wrong and you're not really sure what's happening with that config, it's not doing what you expect, you oftentimes require really deep expertise in the underlying, like Envoy/nginx, whatever the underlying proxy technology is, to really figure out how to solve those problems. And yeah, again, ngrok meets you wherever you're at. It doesn't matter what kind of device or traffic you're running. We have the CLI, the APIs, the SDKs. So it's really just like choose your own adventure in terms of like how you want to get things connected or how you want to use the networking tools. So yeah,
Awesome.
It is finally time for a demo, but why don't we make sure there's no questions first?
Yeah, there are a few questions. I think some of these we might be able to get to kind of in the like if time allows section, but maybe where we can start is I don't know if you've had much experience, Alice, with we actually have you know two different questions about the difference between ngrok and something like MuleSoft. If you've ever like interacted with that yourself, if we could cover that a little bit. Otherwise, it might be an opportunity for us to follow up after the webinar and get them some more detailed information.
Gotcha. I have never used MuleSoft myself, but I knew a lot of people who had horror stories about it. That is kind of my only real experience with it. I've never really talked with anyone in depth about what using MuleSoft looks like, though.
Right, right. I don't think I've heard much heard much of, you know, prospects or customers coming into ngrok who were using MuleSoft before and were looking for an alternative to that. So I think for us, that will absolutely be a takeaway from this is to go back and do a little bit of research and we can get, you know, we can reach out to those folks who are curious about this, you know, compare and contrast between ngrok and MuleSoft with some more information. Absolutely. The other question was about multi-cloud authentication and authorization.
Mhm.
And I know we're going to try to do a bit of like talk a little bit about traffic policy and how that enables those things. So maybe we can like kind of come back to that question after the demo and see if it's been answered through what you did, or
Gotcha.
we can try to take a few minutes to cover that as well.
Gotcha. I don't know. Why don't we jump into the demo? I don't want to run too far over
Let's
time.
do it.
Let's go off of that slide. Awesome. Can everyone see my screen okay? I'm going to make this terminal font bigger. I know I've got a pretty wide screen.
I can see it. Hopefully that is the same for everyone else. If not, yeah, please let us know in the chat if you're having any issues.
All right, so I also have some configuration. So for this use case, I wanted to keep it simple. So I am running 2 K3D clusters on my local machine. So I have this one, K3D demo Alamo, and then I have another one, K3D demo Bronx, and we're going to set some stuff in them. The fact that they're running on my local machine doesn't really matter. You could think of these as like one is an AWS, one is a GCP. From a ngrok perspective, it really doesn't matter where it's running. So I've gone ahead and taken the liberty of installing the ngrok operator in both of these. This is going to be like a mostly Kubernetes demo. And so the setup for that, you just sort of like use our Helm chart to install it. You can go check out the docs if you are interested in trying this out yourself. And yeah, I'm going to jump right into it. So I have these two services. They're really running the same image, but we're going to call them Alamo and Bronx. And so pretty much this is just going to say, hey, this city name is Alamo, and this other one is going to say, hey, city name is Bronx. And we're going to deploy one of these into each of our clusters. So which one am I connected to right now? Bronx. Okay, let's apply that one first. All right, and then we'll switch to our other cluster. And we'll apply this service in that one. All right. So if we take a look, we've got our pods running for our Alamo deployment. This is the Alamo cluster. And we want to expose this service so we can get traffic to it. And so this is typically like your first quick step setup guide for getting an API gateway installed. And with ngrok, within the operator, I'm going to go ahead and do this using a custom resource called agent endpoint. So this one's really simple. All it's really saying is, hey, the upstream is going to be alamo-service.default because that's the namespace it's in. And it's going to be over HTTP. If you were to have some different protocol like TLS, HTTPS, or a different port, you can just specify that all in the URL. And then I'm going to specify the URL that I want this to be reachable at. So for ngrok, you can just set up any of them with the .ngrok.io one, and it'll automatically provision you domain insert for that, and you don't need to do anything else. If you were to come into the ngrok cloud here, you do have the ability to specify your own things like domains, and you can configure like a domain that you already own to work with the ngrok network. You can bring your own TLS certs and everything. I'm just going to go ahead and use the ngrok.io free domain so we can get this demo up quicker. Oh, let me make sure this is the right one. This is the Alamo cluster. Yeah. And I have, wait, did I apply? Okay, yeah. We are still connected to the Alamo cluster, and we did apply the right service. I'm going to set this agent endpoint. All right, and so if I were to come back over to my ngrok, this is the web interface here. If you just go to like dashboard.ngrok.com or ngrok.com and sign up for an account. If I look at my endpoints, I can see I have an endpoint right here. And so if I were to come over here and make a request to that, I can hopefully make this text a little bit bigger. It's pretty small. It might be too big. Yeah. So we can see that all this service really does is it tells us, the city name that we specified, so we can tell which cluster and service we're connecting to. And then it'll tell us like what our path is if we were to input any kind of different path. So we've got our Alamo service connected. Let's go ahead and set up the Bronx service as well. All right, and if we just double check, we should have our Bronx service online as well now. And if we were to make a request to that, we are able to access that. So super quick to set up just getting traffic routed to these, but these are exposed to the public internet right now. And let's just for this use case say that I don't really want that. I want these to be private so that, they can't be reached by the public internet, at least without going through something like auth and authentication and that kind of thing. So for that, we're going to set up another resource called a cloud endpoint. An agent endpoint is a little bit different from a cloud endpoint in that an agent endpoint is essentially local to wherever the agent that's running it is. In this instance, the ngrok operator is serving as our agent. So as long as the ngrok operator here is connected to the internet, these agent endpoints that are serving this traffic will be online. But if I were to, destroy this Kubernetes cluster, or, there was some network outage, it was to go offline, these would not be reachable. A cloud endpoint is a little different in that it doesn't directly specify anywhere to route the services or route the traffic it's receiving. But since it lives entirely in the ngrok cloud, so it is persistent no matter, what happens to your agents. And so this allows you to do some traffic processing and things like that within the ngrok network before it gets dispatched to its final destination. And it also makes sure that you have a persistent URL that is online no matter what. And so I'm going to go ahead and take this cloud endpoint, and it has this thing called a traffic policy in it. And the traffic policy is really like the most powerful thing in terms of ngrok configuration for deciding what happens with requests and responses. So we have these things called phases. So I just want to say like, hey, on HTTP request, I've got an expression. If the path starts with /alamo, I'm going to forward external to that HTTPS thing I had before. And that is going to essentially like reroute it through the public internet back to the Alamo service. And so if I go ahead and apply this really quick. Oh, we are still connected to the Bronx cluster. With the cloud endpoints, we have the option of creating them as Kubernetes custom resources. If that's where you want to manage them, you have the option of creating them through the ngrok cloud as well, or the API or the SDKs. So if you don't want the configuration to live on your Kubernetes cluster, you don't need to do that at all. I simply chose to do it this way because it's a little bit easier to read than making a curl request or setting up some custom piece of software that would consume our SDKs. Let me get out of full screen here. Okay. Now if I go ahead within my Kubernetes cluster, if I get you can see I have my cloud endpoint here. And I set up a new URL for this cloud endpoint because I'm already using this other URL in my agent endpoints. I'm already using Alamo service and Bronx service. I want like one central endpoint that can route to both of these. So that's why for my cloud endpoint, I set up Alice DevOps Webinar, and that's going to be our new one that we're going to connect to for the cloud endpoint. So if I go ahead and make a request to this, we're going to get this error page, and it's basically going to tell us that this traffic policy is not terminating. What that means is that since the traffic policy, as I mentioned, doesn't specify any sort of upstream, it's kind of on you with however you build the content of your traffic policy to make sure it terminates if you don't want to receive one of these. So that's as simple as doing something like, I have this expression here that will only route this if I start with the path /alamo. If you wanted to have like a default 404, you could just add one last one at the bottom that if it didn't match any of the expressions or rules above it, it would route to some service that handles 404s, or you could even do like a static 404 response page within the traffic policy itself. So if we go ahead and try Alamo, we get connection to our Alamo service, and it tells us our path is /alamo. All right, so I mentioned we don't want these services to be routable from the public internet. We set up our cloud endpoint so we have like one central place to route to all of our services, but these individual services are still exposed to the internet, and we don't want that. So something you can do with ngrok endpoints, this is for both agent endpoints and cloud endpoints, is if you make the URL that they are, going to be exposed to, instead of something like .ngrok.io, you can name it anything you want. And if it ends in .internal, that will make it so that the endpoint can only be routed by you within your ngrok account from things like a cloud endpoint. And it will make sure that it is not exposed to the public internet. So I'm going to go ahead and apply these really quick, and we're going to change our agent endpoints to be internal. Let me double check which cluster we're connected to. All right, we still are connected to the Alamo cluster. That's the right config. And then we'll apply the same thing for our Bronx service as well. Oops, I keep full screening my thing without meaning to. All right, we got our 2 endpoints configured. So if we were to come back over here, we can see this is our DevOps Alamo service URL. If we were to do it again, we can see we get an error because ngrok is just telling us, hey, this thing you input doesn't exist. If you were to do this with a custom domain and not use the free ngrok domain, you wouldn't even get this. It just wouldn't route. So we've successfully taken our services and made them private. Now, as you saw first, I had my ngrok traffic policy saying on HTTP request, we're going to forward external. We can do the same thing, but we're going to say forward internal as well. So this is going to internally forward to this and obviously make sure that if this internal endpoint exists, that we own it, because we're not going to be able to forward to someone else's internal endpoint. But it's also going to skip the step of routing through the public internet. So as soon as ngrok receives this request up at Alice DevOps webinar, it's going to look up the internal endpoint that we're routing to, and it's going to route directly to that instead of trying to reroute through the public internet and match that agent endpoint, because it can't do that. So I'm going to go ahead and change my cloud endpoint. And I created it in my Alamo cluster, so I'm going to go over there. All right, so we've got our cloud endpoint updated. And if I want to go ahead and go back to it, which tab was I using? Yeah, it's this one. And we were to type /Alamo, we can still get routed to our Alamo service, even though it's not exposed to the public internet. So this is kind of the first step in setting up a configuration for like protecting your services from the public internet, but securing them behind like authentication and stuff. Obviously, this traffic policy doesn't enforce anything like authentication, but if I wanted to, I could add that easily right in here. Another thing I wanted to showcase really quick is that this doesn't need to be Kubernetes. So within the ngrok CLI, like you can just download it and run it like that. I want to set up another endpoint as well. Like you can imagine this is something like running on a virtual machine, or maybe this is like some embedded device or some smart home device, whatever the case is. I have this and I want to run it from the CLI, but I also want to connect it to that same cloud endpoint. So within the ngrok CLI, you can do something like ngrok config edit, and it'll start editing your, CLI config file. I'm not going to open that up right now because it has in it our auth token that tells the ngrok network like who we are and what account we belong to, and I don't really want to show that to everyone. So this is what my ngrok config file looks like. We have an endpoint specification. I have one, it's called demo, and I'm going to call this one Alice ngrok CLI.internal. Again, I don't want my laptop exposed to the public internet without going through auth. And for the upstream, within my Docker environment, I am running the HTTP bin service locally on port 8080. So I would like for my cloud endpoint to be able to route to both of my clusters, but maybe also my laptop as well, or some other device that's running the ngrok agent that is not a Kubernetes cluster. So in this case, I'm going to apply this and I'm going to say, hey, if the path starts with local/info, I want to send a custom response. And this is going to happen directly from the ngrok network before it even reaches your computer. So the upstream is not going to receive anything in this case. ngrok network directly is going to send a response. It's going to say, hey, this endpoint was created from the ngrok CLI. But if this expression doesn't run, right, if we don't have /local/info, we want to be able to URL rewrite. So that's another action you can do to modify any aspect of the URL you want. And since HTTP bin doesn't know what /local is, I'm going to just rewrite it to /. So I'm going to go ahead and just come over to another tab, and I'm going to go ngrok start demo. And you can start more than one endpoint at a time if you have them, but I only have one for this example. So you can start this in the background, but if you leave it open, you kind of get this little interface that'll tell you like what's going on with this connection and stuff. All right, so I've got my agent running, and it's going to serve this up from this internal endpoint. So the only way we're getting traffic to it is if we have a cloud endpoint. So let's update our cloud endpoint one more time, and we're going to add /local as one of the expressions. So if it matches that, we're going to forward internal to this endpoint, but this is the one that started from my CLI. Okay, we're still connected to the cluster I created my cloud endpoint in. All right, and so I've got that updated. If I come back to my browser and I type in /local/get, because get is one of the things that HTTP bin understands. It's a path it supports. /local isn't. We're rewriting /local to just slash. So HTTP bin should get a request at just /get. And this is our response from HTTP bin. As you can see, it's the exact same thing as if I were to go to localhost and I were to go to /get. All right, so I just wanted to show that really quick to showcase like it really doesn't matter what kind of environment you want to wire up. It's all super easy to get connected. You can kind of think of cloud endpoint as like the entry point, which is going to like run all of your policies, your auth, your rate limiting, that kind of thing. And then from there, decide where it wants to route the requests to those individual endpoints. And you can keep those endpoints external or internal. It's up to you. Really quick, I want to showcase one more action. If you were to come over to the ngrok docs, though, and the docs for traffic policy actions, you can see there's tons of actions you can use within your traffic policies. You can do circuit breaking, add headers, compression, denying, JOT validation, OAuth, rate limiting, OIDC. There's a lot of them, and we just keep adding more all the time. So traffic policy is a super powerful system where you can kind of just compose like what you want to happen to the request. And so in this case, I'm going to add a rate limit. And since it doesn't have an expression, it's just always going to run. But because it doesn't route the traffic anywhere, it's not going to terminate the traffic policy. So it's going to run this rate limit. And as long as we don't get rate limited, we're going to keep going down and evaluating the next expression up until we get to one that terminates the request or routes it. All right, so if we come back here and we go to our demo again, you can see we still get routing, and we're rate limited. So that's our rate limit policy kicking in. If you wanted to, like let's say I only wanted to rate limit for the Alamo service, I wanted that to not be a global rate limit, you could do something like take the action and just kind of stick it here within the route. So fix the formatting, but you could do something like rate limit, and this would only apply to the ones that matched this expression for /Alamo. And pretty much all of these fields for the traffic policy support cell. A lot of them support regex as well, so you can get really creative with the kind of things that you want to do. One more thing I wanted to showcase is that if you are using the Kubernetes operator, you don't have to use cloud endpoint and agent endpoint directly. We do support ingress resources as well. If you have the mapping strategy annotation that says, hey, ngrok, please make endpoints from this. Another thing is like, how do I bring traffic policy to ingress? So we have an annotation. Traffic policy is, I'm going to bring this one called rate limit, and that is going to apply to this ingress. Within the spec of the ingress, I also want to say like, hey, what do I want to do about the case where like none of my routes match anything? I still want to be able to like serve up a 404 page. So you can use a traffic policy as well with your default backend or a service. It's up to you. And then I want to say, for this one, Alice DevOps Ingress, so this is a different host name, /Alamo, I want to route to my Alamo service on port 80. And so within it, I have these two traffic policies. So I have fallback 404, and that's going to be like our default if we don't match anything. And from my traffic policy, I'm just going to send a 404 page. I don't really care if it's fancy. And then I have my rate limit one. And this one's a little different. I wanted to add some other stuff to this one. So you can see this one, maybe I want to like debug some stuff about my request, right? Like I want to make sure things are working properly. And so I added an expression that's going to check for query parameter debug. And if it is equal to 1, we're going to get a custom response, and it's going to tell us some stuff. So this is an example of like using things like cell and properties of the request within your traffic policies to kind of compose things together. So I want to just send back a response that tells users what their path and agent and version was. But if we don't have this expression, we're going to go ahead and drop into that rate limit again. And again, just to showcase that we've been using HTTP request up until now, but I also want to, on response, say, hey, if their TLS version is not 1.3, let's add a header and tell them that their TLS version is no longer supported. So I'm going to go ahead and apply all of that. Wrong command. All right, and if I go ahead and get my cloud endpoints, you can see here's the one that I initially created. And then as a result of creating this ingress and saying, hey, ngrok, please make, endpoints out of this, it has created a managed cloud endpoint for me. This one has a finalizer on it since it was created by the operator, so you can't just delete it. Even if you were to remove the finalizer and delete it, if that ingress is still around, it's just going to keep recreating this. And so if I were to come back over to my web browser, actually, let's do this with curl. I have Alice DevOps ingress. So let's do curl. I've already typed this out before, as you can see. And so I'm going to say my TLS version is, let's start with 1.3. And we'll make a request to /Alamo. You can see we get our response back, HTTP 200. I'm just kind of printing the headers here. We don't have any sort of HTTP headers added, but if we were to change our TLS to 1.2, we can see we get our deprecation warning header added. TLS 1.2 is no longer supported. And if I were to go ahead and add my question mark debug equals 1, we can see that we get our, I need to actually print out the contents of this. You can see we get our response back from the traffic policy, which is going to tell us what our path was and some properties about the connection and request. So that is kind of it as far as I had for demos. Why don't we go back to questions?
Yeah, we just got a question about that debug header and whether that could be wrapped or protected, let's say, with an authorization check or action. And yeah, I mean, the short answer is yes, like absolutely. It might be a little difficult to, like usually those things, like we want to use JOT validation, like we have to set up an external IDP to get that to work properly for a demo purpose. But yeah, absolutely, that is possible with expressions, and I guess in that case you could chain together. You could do the authentication check first. If the path is correct, the path you're looking for, and the header is present, and if those are both true, then you could pass it through. Otherwise, you can deny it.
Yeah, and since the traffic policy actions, they are evaluated in order, right? So you could do something like, let's say as part of your authentication strategy, you want to like auth people, and based on some, things like claims or whatever from the JOT, you want to stick those in headers so your upstream services can easily consume them. You might want to do something like put a remove headers action first. So you sanitize those to make sure no one's trying to spoof them before you add them with your next traffic policy action. So you can do stuff like that and compose them in order. And depending on how you kind of organize them, it's really up to you. Like you can chain them, you can do all sorts of fun stuff with them. I've seen people build entire websites just based off of traffic policies and no upstream services. That's a little extreme, but just as an example for like how flexible you can get with these things.
Yeah, I think one of our folks even developed a static site generator that would output a bunch of like raw HTML that would and use the API to like upload an entire static site to a cloud endpoint. So yeah, amazing flexibility there. We have another question about ngrok and observability, and that's a great one. So like the question is about the integration with observability tools and what kind of like limitations there are, or like what some of the capabilities are. Alice, I'm not sure if you've like dug super deep into the observability side, but we do have like a couple of options available.
Let me share my screen again for a quick second.
Yeah.
Because, this is something that'd be nice to share because I did mention it. Yeah, so going back to my ngrok platform, if we're to come over to here, we see there's this thing called a traffic inspector. And you can see this is all the stuff that was sent to my endpoints over the course of this demo. You can see we get these little badges here for like the cases when you get like a, I'm not sure if this cloud endpoint had it or not. Yeah, one of these, like 6029, you can see when people are getting stuff like that. And if I were to open this up, right now it doesn't have anything here. But you can see like you can enable full capture if you want to store all this stuff within the ngrok cloud. And you can capture like the body, the values of all the request headers and stuff like that. I would just, if you want to enable full capture, just be careful about like how long you're retaining it for, because if you have a ton of data and stuff that you would get billed for that. So you also have the ability to like export it with this event stream, where you can do stuff like export things to Datadog, CloudWatch, that kind of thing. All sorts of other cool stuff in here I didn't get the chance to touch on. I didn't want to run over time, but TLDR, yes, if you want to look up things like observability, events, that kind of thing, all of that's available within the ngrok platform. You also can export it to any sort of individual platform of your choice.
Yeah, I just dropped a couple links in the chat for anybody who is curious about some of the exporting options as well. Every HTTP request or TCP connection that goes through the ngrok network toward your endpoint, we publish, I think it's 40 different like event, like pieces of data that you can then, as you said, export to different platforms and be able to observe and parse and do all sorts of fun stuff with that if you want to really dig deep into how people are using your API gateways, and like improve how they operate and kind of fix things as you go along and like go along the process of maturing your API gateways and making them really robust. Let's see here. I think that might have wrapped up all of our Q&A. So welcome back, Tip.
Hi, hello. Thank you so much, Alice and Joel, for an insightful presentation. You've covered some incredibly valuable points, and I'm sure our audience has found it as informative and engaging as I have. Before we close out, attendees, if you can please click the survey in the resources section, as your input is invaluable to us. Your feedback does go a long ways here, so please do let us know about that or any other closing or final thoughts that you've got. Once again, you will receive an email in your inbox shortly after we conclude today's session with a link to view it. I would like to thank Alice and Joel for taking the time to join us. It's been a pleasure having you. Thanks for joining this TechStrong learning experience. Looking forward to seeing you all again. Have a great day.